Hey, it's Mr. Shrum, and we are going to get into types of matter. Now, a lot of this may be review. I know we talk about this in middle school science and some of your earlier high school sciences too. So I'll be overviewing a lot of this stuff, but maybe focusing on some of the new stuff. Let's get into the types of matter. Cookies is a mixture. You can see all of the ingredients. We mix it all up into a batter. And then some of those ingredients are in solid states, some are in liquid states. And yeah, so that'll come up later in this lesson. But what we're talking about is matter, things that occupy space. That is called matter. And we typically find matter in three states: solid, liquid, or gas. Now, the states of matter, everything that has mass and occupies space, that is matter. So the food you eat, the air you breathe, almost everything you see, and some things you can't see, are examples of matter. Here on Earth, a lot of the stuff is in solid, liquid, or gaseous forms. There are other special conditions where matter can be created into other states, or matter can be found in two or more states. Plasma, that's when you superheat a gas, and yeah, so you add a lot of heat to a gas and it becomes plasma. Bose-Einstein condensate, or BEC, is when you super cool something. So you remove a lot of heat. In this lesson, we're going to mostly talk about solid, liquid, and gas. You're familiar with solid water, which is ice, whether it's in your fridge, on top of a mountain, or in glaciers. Liquid water flows from faucets, and gaseous water, or steam, is produced when you boil it. So here's a first lesson. I'm going to skip that tutorial. Let me know if you have trouble with it, but it's pretty straightforward. And in that simulation, you observe that particles in a solid are connected really tightly together. And they're very structured, ordered. These particles may be atoms or ions or molecules, and that tight connection gives it definite shape and volume. Particles in a liquid are not as tightly bound together. They can slide past each other and move freely. So they have an indefinite shape. They can shift depending on the container, but the volume stays the same, and they take the shape of their container. Particles in gas collide with each other, but they're unbound and free to move in space between collisions. So they don't have a defined shape or volume. The air around us has no definite shape or volume, and it just expands and takes the shape and volume of the container they are kept in. Those two other states of matter, plasma, like I said, it's when a gas is superheated and it makes this cloud, an electrically charged cloud. The matter in the sun and most other stars are in this plasma super energetic state. On the other hand, the Bose-Einstein condensate, or BEC, that happens when you super cool something. And in that state, the particles of matter look really small and fuzzy. And this was predicted by Einstein and Bose back in 1925. And that's how it got the name. So this goes on to talk about the tightly connected particles in solids and how you cannot compress solids very easily. You can compress liquids a little more easily than solid, but gases are very compressible. The density of a solid is typically greater than the density of the liquid or gas phase of the same substance. Liquid particles are free to move around and glide past each other. And that means there's a bit of space between the particles. And this free particle motion is one reason that liquids are usually less dense than solids of the same substance. But one of the important exceptions is water. And that is because of the way hydrogen bonds with oxygen and the polarity of water. But anyway, ice is actually less dense than liquid water, but that is very unusual compared to every other substance. Gases have the lowest density among the three common states of matter because there's a lot of space between the particles as they're bouncing around and colliding with one another. So that also means they can be compressed. And solids have the highest density, gases have the lowest density, liquids have particles that glide past each other, solids have a definite shape and definite volume, liquids have an indefinite shape, they can change shape, but they always have that same volume. And then gases have neither a definite shape nor volume. Double check. Yes, cool. Now we're going to get into the classification of matter. There are different types of ways you can refer to matter. Elements are the most basic form. Compounds are where you mix two elements together, two or more elements, in fixed ratios. And then there's mixtures, which is the messiest combination. Elements, that's only where one kind of atom, and it's the simplest version of a substance. It talks about alchemy, where people tried to turn metals into gold, and that is just physically impossible because elements are the most basic substance and you cannot convert one to the other. You know, a gold atom is a gold atom. You cannot make a lead atom into gold. Compounds are formed when atoms of two or more elements bond together in a fixed ratio. That's important, fixed ratio. So you see how this is a compound, C6H12O6. These are fixed ratios. Water is also made up of two elements, hydrogen and oxygen. Water is a compound. Table salt, which is sodium chloride, is a compound. Sugar is a compound made of three elements, carbon, hydrogen, oxygen. Baking powder is another compound that has four elements, sodium, carbon, hydrogen, and oxygen. So elements are the most basic, simple substance version of themselves. Compounds can be broken down into those simple elements by with chemicals, right? Or some chemical process. Mixtures are combinations of two or more elements, compounds, or both. And they are not chemically bonded to each other and are not mixed in a fixed ratio. These can be separated by purely physical means. So compounds are chemically bonded to each other. Compounds are chemically bonded atoms, and they can be separated through a chemical process. Mixtures are not chemically bonded, so they have to be separated by purely physical means. Air around us is an example of a mixture. It contains several gases like oxygen, nitrogen, carbon dioxide, but they're not bonded with one another and they're not in any fixed ratio. And we can further classify those into homogeneous mixtures or solutions. Homo means the same. That's what that prefix means. Homogeneous mixtures have a uniform composition So if you look at this coffee, it's a mixture of sugar, water, and coffee extract. But if you look at the coffee, you can't see the different components. It all looks like one substance. That's what uniform composition means. It all looks the same after it's been mixed. And we say that's homogeneous. And if you look at the solution, it will be clear or transparent. It's not going to look cloudy. And that's because all of these substances are in a liquid state. You can't see the sugar, coffee extract, or water separately. And solid versions of solutions do exist. Stainless steel is a solid, and that's made up of iron, carbon, phosphorus, sulfur, and nickel. It has a uniform composition. You can't see the different types of metal in stainless steel. Heterogeneous mixtures. Hetero means different. So unlike the homogeneous mixtures, heterogeneous mixtures have different compositions. It is not a uniform composition. You can see the components separately in these mixtures. So the example here is a green salad, whereas coffee is all mixed together. You can't really see what's what. A salad is mixed up with different vegetables, different ingredients, and they never quite mix together where it looks like one big glob of salad. Like you can tell the individual components. Concrete is another good example of a heterogeneous mixture. It's made from lime, sand, and gravel. That chocolate chip cookie that we were talking at the beginning of this lesson, that is a heterogeneous mixture as well. You can see the chocolate chip cookies mixed in there. However, there are different types of heterogeneous mixtures. This salad would be referred to as coarsely mixed. But there are heterogeneous mixtures called colloids or suspensions. A colloid consists of minute particles. Minute means really tiny, spread in a solid, liquid, or gas medium. So fog, milk, and butter are examples of colloids. Fog has tiny droplets of liquid water mixed in air, a gaseous medium. Milk is a mixture of solid calcium and cream in a liquid medium. Butter is a mixture of water in a solid medium. A suspension consists of larger particles that settle after the mixing process stops. Fine sand is, if you mix fine sand and water, you stir it up, it'll look cloudy for a bit, but after a while, the sand settles to the bottom and you can tell the liquid water from the solid sand. So colloids are like milk. It always looks kind of cloudy. Suspensions will have larger particles settling at the bottom. This is a concept map. So we've been talking about matter. You can separate matter into three categories: elements, the most basic form; compounds, which is a fixed ratio of elements mixed together; mixtures is a messy mixture, really, of elements or compounds tossed together. And then you can break those mixtures down into these homogeneous mixtures, which are solutions. That's stuff that you cannot tell the ingredients from one another. Heterogeneous mixtures, you can break that down into coarse, colloids, suspensions. So coarse mixtures, think of that salad where all the ingredients are just thrown together. Colloids, like milk, really tiny particles floating in a medium. Suspensions, larger particles in a medium that eventually settle down. Okay. These are 4 examples of elements. So we have oxygen, gold, hydrogen, bromine. You can read about each component here. I'll leave it up for a few seconds. You can pause the video to look at these descriptions. Keep right-clicking for some reason. All right, so those were the 4 examples of elements. We have the 4 examples of compounds. That's hydrogen peroxide, methane, one of the greenhouse gases that contributes to global warming, sulfur dioxide, another air pollutant, but it's also used for other uses like winemaking and preservatives. And then we have soda ash or sodium carbonate. You may have it as a cleaning agent in your house. You can also use it to make glass. And then finally, we have mixtures. So homogeneous mixtures, think of vinegar, brass, like the stuff you make instruments out of, mostly. It's an alloy. That's a metal that is a mixture of other ratios of metals. Then you have heterogeneous mixtures. Milk is a colloid. You can see the different components under a microscope. And then we have muddy water. That is a suspension. So eventually that those large particles will settle down in the water. But okay, mayo is made up of eggs, oil, and vinegar. Under which category should be classified? We're going to go with colloid. It's a heterogeneous mixture. It's not transparent. It's like a more solid form of milk, but with different ingredients. Then we go into separation techniques. Compounds are chemically bonded together. So if you want to separate compounds, you need to chemically separate them. Mixtures are physically mixed together. So you need a physical process to separate out mixtures and the elements within them. So an example of a physical process is removing salt from seawater. If you just let seawater stand in the sun, the water will evaporate and leave behind salt. And that is how salt is made from seawater. So that's a physical process, not a chemical one. And we're going to learn about 3 common separation techniques: filtration, distillation, and chromatography. Filtration, think of brewing tea or coffee. You may use tea bags, and those tea bags have filtered paper around the tea leaves. The filter paper holds back the solid particles of those tea leaves, but lets liquid flow through the filter paper. So that is what filtration is. Some type of cloth or paper holds back large particles and lets smaller ones through. And there's an ancient technique for purifying water. You filter water through very fine sand or fine coal powder. And here's a good diagram for that. Distillation, that is when you boil a liquid, you capture the steam, and then you condense the steam back into a liquid form. And that is how you separate the impurities or other substances in a liquid. So if you have water, you boil water and you capture that you capture the water in some type of flask. Yeah, a clean flask. And then you cool that steam back into water and it condenses into water. That condensed water is pure. Only water molecules were evaporated and then condensed. So you lose all those other impurities. And fractional distillation is used to separate liquids with different boiling points in a homogeneous mixture, like crude oil. This video goes into that. So on the small scale, crude oil is made of hydrocarbons, and in its current state, like its natural state, it's not very useful. People have to separate out the hydrocarbons and the different versions of crude oil to make it useful to us. So they start out with putting crude oil in the bottom. They have a flask, a thermometer, and they put it in boiling water. It evaporates and then is placed into this flask. And then in some cases, they use a Bunsen burner to heat it. And then it's distilled further, different substance. So like you can separate them out because they have different boiling points. So you boil this out of it at this temperature, and then you boil this out of it at this temperature, and that's how you separate it out. And they do that at the large scale. So think of a refinery as just a giant version of this. And this is how they separate out the various hydrocarbons and make crude oil useful to us. It's a very interesting process. It does using fossil fuels. Eventually we'll have to move away from this if we're going to build a sustainable world for the rest of humanity after us, but we'll see. And the last chemical separation technique is chromatography. That refers to techniques used for analyzing the dissolved substances in a mixture or for separating them out. So scientists use chromatography to identify the precise drug present in urine or blood samples, or separating proteins in a given mixture. It's used in biotechnology, forensic science, and sports medicine. And it's based on the principle that the components of a mixture have different sizes and solubilities. So they're going to travel through the chromatography system at different speeds. And the system has two states or phases of matter. You have the mobile phase, which is the liquid or gas, and the stationary phase, which is the solid. The components of a given mixture are distributed between these two phases and get separated based on their chemical attraction or affinities for the stationary phase. Here's an experiment, but I'm just gonna see if we can look up a video. Yeah, there you go. Maybe that'll work.
Hey everybody, I just want to show you a simple forensic technique that we can use called ink chromatography. Okay, so we've got different pens, and so we're going to go and put a dot on, this is just normal filter paper. You're going to just use paper towel as well, something that's going to absorb the liquid. So we're just going to put, I might actually use my pencil first of all and just make some marks here. So 1, 2, 3, 4, and then CS for the crime scene. Okay, so we've actually labelled our pens, so we know which one's which. So pen 1, and
2, pen 3, pen 4. Now I'm going to sneakily,
without showing you, make one of these the crime scene pen. Okay, so no peeking. Use a solvent. So a solvent's just a liquid in which stuff dissolves. And we're actually going to use methylated spirits. And we're going to use it in a beaker, but you don't need to use a beaker, you can use any sort of cup. And I'm just going to use a paddle pop stick just to hold it so it doesn't fall over in the liquid. So it's just going to sit up like this. Now, this is the most important part. We don't want to cover these dots, our ink, in the methylated spirits. We want to finish the methylated spirits around about here. Okay, and I'm just going to put it in. Now, you'll see that the methylated spirit starts to get drawn up through the, it gets drawn up through the filter paper using capillary action, and it's going to go up through our dots of ink, and it's going to drag the ink up and separate it into different colours. Now, the way it separates based on how well it dissolves, how soluble it is. So the colour that's the least soluble, that's not going to go as far, and the colour that's most soluble is going to stretch out the furthest. So we're going to time lapse this to make it a bit quicker for you. Okay, so can you guess which one the crime scene is? It's probably not 1. It's probably not 4. And I say that because the crime scene one's got a lot more blue in it, so that's why I definitely don't think it's 4. And so we're trying to work out if it's 2 or 3. I'm guessing that it's probably 2. You can see how 3 has a lot more of the red early on. But so the pattern that you see here is based on, even though the colours of these pens look black, you can see that they're not actually black at all. They're made up of a number of different colours. And the pattern we see depends on how soluble each of those different pigments are. The more soluble, the further up they go. The less soluble, they get deposited earlier on.
So that's a pretty cool video. Very easy to show you what they mean by how different things are soluble at different levels within a mixture. So that black ink is mixed with various pigments. As the water moves upward along the filter paper strip, different pigments present in the black ink separate out at different points. After drying the paper, there is a colored pattern on the strip. What conclusion can we draw? Black ink is made up of different colored pigments, and chromatography separates it into its constituent components. All right, so lastly, we're going to match the filtration techniques with the definitions. So filtration, that was the first one we looked at. That was when we use some type of material, some medium to separate solid particles from a liquid. There we go. Distillation is when we boiled something and then condensed it back. That's that one. And then chromatography, that's when you separate mixtures based on different sizes and solubilities of the components, like that ink chromatography. So good deal. And then summary, this just summarizes everything we've looked at. This is a good slide to come back to. It shows solids, liquids, gases, and the various criteria, how the particles interact, the movements of the particles, the space between the particles, how easily compressed a type of matter can be, the density, and the shape and volume. So this is very good to come back to or take notes of. So go do that. Then this is a good slide to show you all of the summaries of how to classify matter, elements, compounds, mixtures, and then how to further classify mixtures into homogeneous mixtures, which are solutions, and heterogeneous mixtures, which can be colloids, suspensions, or just plain coarse. And that's it. So hopefully you found that tutorial helpful. And if you have any questions, message me in Canvas and I will help you. But until next time, have a great day and I will see you all later. Bye.